we're discussing quadratic graphs. This is included in IGCSE syllabus as well as GCE syllabus. Alright, so before starting with quadratic graphs, let's quickly revise what are linear graph. So linear equation is y is equals to mx plus c, the general form of a linear equation, where m is the slope and c is the y-intercept. So for an equation 4 is y is equals to 4x plus 3, the slope will be 4 and the y-intercept would be 3. Now when the slope is positive, the line is supposed to look like this. When the slope is negative, the line is supposed to look like this. It will be a falling line. If the value of m is undefined or infinity, then the slope will look like this, undefined slope. And if the slope is 0, then the line will look like this. So to plot this particular line, you will make a table. You will take any three values of x. Let's say I'll take 0, 1 and 2. Then we'll get three corresponding values of y. The first one will be 3, the second will be 7, and the third will be 11, and so on. Then you'll plot these 3 points on a graph and then join the 3 points with a ruler, and you'll notice that this line will be cutting the y-axis at 3, and it will be a rising line because the slope is 4, which is positive. So that's all about linear graph. Let's quickly do one question related to linear graph before we jump to quadratic graphs. This is the first question of the worksheet. I'll attach the link to the worksheet in the description as well. Okay, so question number 1, state which of the figures below could be the graph of part A, y is equals to minus x minus 1. So for y is equals to minus x minus 1, the slope is negative 1. Slope is always the coefficient of x. And the y-intercept or c is also minus 1, which is this constant. So our graph should be a falling graph, and it should cut the y-axis at minus 1. So it should look something like this. Now which of these 6 graphs look like this? It is figure number 2, I believe. Yes, it's a falling line which is touching the y-axis somewhere around minus 1. So the first answer is 2. Part B, y is equals to minus x. Now the slope is minus 1 and the y-intercept is 0. So it should be a falling line which should touch the y-axis at 0. So it should be figure 6, a falling line which touches the y-axis at 0. Okay. Part C, y is equals to x plus 3. So the slope is 1 and the y-intercept is 3. So it should be a rising line which cuts the y-axis at 3. So that would be figure 3. It's a rising line and it's cutting the y-axis somewhere over here at 3. Okay. Then we have y is equals to x. The slope is 1 and c is again 0. So a rising line that cuts y-axis at 0. So this is the line. So the answer for part D is 1. Then we have y is equals to minus x plus 3. So it should be a falling line since slope is negative 1 and the y-intercept is 3. So falling line that touches the y-axis at 3. So that should be figure a falling line that touches the y-axis at plus 3. So it will be figure 4. Yes, this one. it is a falling line and it's touching the y-axis at +3. And then part F is y is equals to x minus 1. So again the slope is +1 and c is -1. So a rising line which touches the x-axis at -1, so that is figure number 5. Okay, coming to the quadratic graphs. For an equation, quadratic equation y is equals to x square, the graph is supposed to look like this. It will be a U-shaped graph. For a graph for the equation y is equals to minus x square, the graph is supposed to look like this. It's an inverted U graph. And if the equation is y is equals to x square, let's say -3, the same graph will go 3 places down, 3 units down. So now it will cut the y-axis at -3. So this -3 is actually the y-intercept where the graph will cut the y-axis. Here it was 0. So the graph was cutting the y-axis at 0, right? So now if I change the equation to y is equals to minus x square, let's say +2. Now this same graph will go +2 units up. So it will still look like an inverted U, but it will cut the y-axis at 2. Now let's go to the worksheet question. Okay, so question number 2. State which of the figures below could be the graph of part A, y is equals to minus x square plus 4. So minus x square means the graph will be in inverted U shape, and plus 4 means it will be cutting the y-axis at 4. So this will be figure number 2. Part B, y is equals to x square, so that will simply be figure number 1 like we just discussed. Next, part C is y is equals to minus 2 plus x square. Now plus x square means it will be a U-shaped graph, and minus 2 means that this U shape will be cutting the y-axis at -2. So that will be figure number 4, a U-shaped graph which is cutting the y-axis at -2. So 4, figure 4. Okay. Part D, minus x square minus 2. Minus x square means inverted U graph which will be touching the y-axis at -2. So inverted U which touches the y-axis at -2, so that's figure 5. Next is x square plus 4. So U-shaped and 4 units up, so figure 6. And then minus x square is simply figure 3. Okay, so the next type of graph would be of the form y is equals to, let's say, x minus 3 whole square. Previously we just discussed the graph of shapes like y is equals to x square plus 3. Here the 3 is outside of the whole square. So the graph, let's quickly revise, it will be U-shaped graph which cuts the y-axis at 3. But here the -3 is inside the whole square. So what happens now, you simply substitute x minus 3 is equals to 0, which gives us x is equals to 3. So the graph will simply be a graph like this which cuts the x-axis at 3. Now this -3 inside the whole square will move the graph 3 units to the right. Previously the 3 was moving the graph 3 units up or 3 units down if it were -3. Now when we write a number inside the whole square, this thing moves the graph either to the right side or to the left side, not up and down anymore. And if it's -4, it will move graph 4 units to the right on the x-axis. And if it were +4 whole square, it will move the graph 4 units to the left on the y-axis. So here. Okay, so a few more examples. Y is equals to, let's say, x plus 5 whole square. This will move the graph 5 units, to the left, not to the right, because like we just discussed, you substitute x plus 5 is equals to 0, so the solution or the root of this equation is -5. So the graph shifts 5 units to the left. Similarly, for a graph like for x, let's say -8 whole square, this will move the graph 8 unit to the right, so it will look something like this. Also, if the equation is something, if the equation is, excuse me, yes, so if the equation is y is equals to -x, let's say +4 whole square. Now, because of this minus, the equation will have a negative x square coefficient when we'll open the bracket. So that means now the shape will be an inverted U graph. So it will be something like this, and the rest working will be the same. When you substitute x plus 4 is equals to 0, we get x equals to -4. So the graph will be of inverted U shape, which will shift 4 units to the left. Rest will remain the same. Question number 3. State which of the figures below could be the graph of part A, x plus 1 whole square. So the figure will move 1 unit to the left. So it could be this graph or this graph. Which one to choose? Do we have any other equation like this? Yes, we also have part D. Look at part D, which is x plus 3 whole square. So this one will move the graph 3 units to the left. So the graph for this will be figure 3, since it's further to the left, and the graph of part A will be figure 2. Similarly, for part B, it's x minus 3 whole square, so the graph will be moved 3 units to the right, so that would be figure 1. And then part C's graph will be moved 1 unit to the right, so that would be figure 4. Alright, next type of equation is when we have something like this: x plus 3 bracket x minus 2. So this is a quadratic equation. The coefficient of x square will be plus 1, because when you open this, you will get x square minus 2x blah blah something something. So the coefficient is x square, so that means the graph will be a U-shaped graph. Now equate this is equals to 0, we'll get x equals to minus 3. Equate this to 0, we'll get x equals to 2. So the two solutions, or the two roots, are 2 and minus 3. So graph will be a U-shaped graph, which will cut the x-axis at 2 and minus 3. Similarly, if we have an equation y is equals to, let's say, minus x plus 1 and x plus 2. So now the coefficient of x square will be negative x square. Open this, you will get negative x square, negative 2x plus x plus 2. And so it's a quadratic equation whose coefficient of x square is negative. So the graph will be an inverted U graph, right? And now let's look here. When we'll equate this to 0, minus x plus 1 is equals to 0. We get minus x is equals to minus 1, which gives us x is equals to 1. This is the first root, and the next root is, or the solution is, x is equals to minus 2. So the graph will be inverted U graph, and it will cut the x-axis at minus 2 and 1. So the graph will be something like this. Alright, now let's do the next worksheet question. Question number 4, which says state which of the figures below could be the graph of part A, x minus 1, x plus 3. So the solution will be x is equals to 1 and x is equals to minus 3, and the coefficient of x square is positive. So it will be a U-shaped graph which will cut the x-axis at minus 3 and 1. So I guess this is the graph for question for part A. So this would be 1 and this would be minus 3. This would be minus 3. This is also a possibility, but here we have a bigger positive value and a smaller negative value, which is not the case for part A. Our positive value should be smaller, which is 1, and our negative value should be bigger, which is minus 3. So figure 1 is the answer for part A. Part B, for part B, the equation will open up to minus x square. So it will be an inverted U graph, and the roots will be, one root will be x is equals to 4, and the other root will be x is equals to negative 1. So we're looking for an inverted U graph which cuts the x-axis at 4 and minus 1. So this would be it. This can't be it, because it has a smaller positive value and a bigger negative value. Our positive value is bigger and the negative value is smaller, so figure 3 would be the answer. And then for part C, again it will be an inverted U graph because of minus x square, and then the two roots are x is equals to minus 2 and then x is equals to 2. So an inverted U graph which cuts the x-axis at 2 and minus 2. So this would be it. So symmetrical graph, same weightage to the positive x-axis side and the negative x-axis side. So the answer for part C is 6. Alright, another type of quadratic equation is y is equal, or another form of quadratic equation, x minus 3 whole square, let's say plus 2. So the coefficient of x square is positive, so it will be a U-shaped graph. Minus 3 will take the graph 3 units to the right, and plus 2 will take the graph 2 units up. So the graph would look like this. It will be cutting the it will be passing through the point 3, 2. Alright, this point is called the turning point, but we'll study this in detail the next year. Okay, what about the equation y is equals to x plus 5 whole square, let's say minus 3. So the plus 5 will move the graph 5 units to the left. So here minus 5. Now this graph will also move 3 units down because of the minus 3. So the graph will be something like this, cutting the passing through the point minus 5, minus 3. What if the graph is something like y is equals to minus x plus 2 whole square plus 1. So because of the negative sign outside of the square, the coefficient of x square will be negative x square. When you'll open this whole thing, you'll get an equation in the form of negative x square, which means inverted U, and the rest would be the same. The root will be negative 2 x will be, when we equate this to 0, we'll get -2, and +1 will move the graph 1 unit up, and it will be an inverted U-shaped graph. So something like this, inverted U, which will be passing through the point -2 and 1. Question number 5. State which of the figures below could be the graph of x minus 3 whole square minus 2. Now, x minus 3 whole square will take the graph 3 units to the right, and minus 2 will bring the graph 2 units down. So 3 units to the right and 2 units down, so that will be figure 3. For part B, it's x plus 3 whole square, so the graph will go 3 units to the left and 2 units up. So figure number 2, 3 units to the left and 2 units up, so figure 2 simply. Question number 6. State which of the figures below could be the graph of part 1, equation minus x plus 5 whole square plus 1. Part 1, y is equals to minus x plus 5 whole square plus 1. Let me write it over here. Y is equals to minus x plus 5 whole square plus 1. The minus sign is outside of the bracket, so when we'll open this, we'll get minus x square, equation in the form of minus x square. So the shape of the graph will be inverted U. So it's either this or this. Now let's see which one of these two is it. So equate this to 0 and we get x is equals to minus 5. So the graph has to shift 5 units to the left and 1 unit up. So it is this one, figure C simply. So the answer for part 1 is figure C. Part 2 is y is equals to minus x minus 5 whole square plus 1. Again the negative sign is outside of the bracket, so it will be an inverted U graph again. It will move, when we equate this to 0, we get x equals to plus 5, and the graph will go 1 unit up, so it is figure B for part 2. For part 3, now part 3 and part 4 are slightly trickier. Part 3, minus x plus 5 whole square plus 1, y is equals to this. Apparently it looks like that the coefficient of x square is negative, but it's not. When we'll open this using the formula a square plus 2ab plus b square, or let's just rearrange to 5 it. Let's just rearrange it to 5 minus x whole square plus 1. Open this with a square minus 2ab plus b square, so we get a square minus 2ab plus b square plus 1. So notice the coefficient of x square is positive, so it will be a U-shaped graph. So a U-shaped graph that whose root will be, or whose values of x will be x minus x plus 5 is equals to 0, so x is equals to 5. So it will move 5 units to the right and then it will go 1 unit up, so that is figure D. And similarly for the last one, we have y is equals to minus x minus 5 whole square plus 1. Again, since the negative sign has the square on it, negative of x has a square on it, so it will become positive x square. So the graph will be a U-shaped graph. Equate this to 0, minus x minus 5 is equals to 0. So x is equals to minus 5. The graph will move 5 units to the left and then 1 unit up. So that is figure A for part 4. Here, the next question is, which of the figures shown below could be the graph of y is equals to x square plus 2. So that is simply a U-shaped graph that's moved 2 units up, so that's figure 3. Part B, the graph of x minus 2 bracket x plus 1. So the roots are simply x is equals to 2 and x is equals to minus 1. So that would be figure 2. It can't be figure 4, although they look a little alike, but here the negative value is bigger and the positive value is smaller. In our case is actually the opposite, so that's figure 2. And figure 3, for part C, the coefficient of x square is negative. So that means the graph will be inverted U. So we only have figure 1, which is an inverted U graph. So the answer for part C is simply figure 1. Question number 8. Okay, so the sketch shows the graph of y is equals to ax power n, where a and n are integers. Write down a possible value for a and a possible value for n. So this is actually a very straightforward question, although it looks a bit tricky in the start, but it's actually pretty simple. All you need to do is find a possible value of a. Now notice that the graph is inverted U shape. So a has to be a negative value. The coefficient of x will be negative, so use any negative value, write any negative value. I'm writing -1, -2, -3 would work as well, as long as it's an integer. Keep that in mind, right? So the next is write a possible value for n. So this is a quadratic graph, so the power of x has to be 2. The power can't be 1 because a linear graph looks like this. It can't be cube and so on because a cubic graph looks something like this, which you'll learn in grade 10. So the only possible answer for n is 2, and for a you can write any negative value.
Question number 9. Write x square minus 7x plus 5 in the form x minus a whole square minus b, which means we need to change the given form into completing square form. For that, first we determine the coefficient of x, which is minus 7, then we divide it with 2, which gives us minus 7 over 2. So we'll write x minus 7 over 2 whole square. We've written negative because of this negative sign in the question. Then we add a value k to it. Next we have to find the value of k. For that we ignore these two and simply take 7 over 2 whole square. 7 over 2 whole square plus k is always equals this constant value, which is 5. So now find the value of k. In my calculator I am writing 5 minus bracket 7 by 2 whole square equals, I am getting minus 29 over 4. So the completing square form is, we get x minus 7 over 2 whole square minus 29 over 4. This was part A. Part B says, hence, means using this answer write down the minimum value of the quadratic expression. Hence means we need to use the given answer to find the minimum value. Either use the graphical method, roughly plot a graph of this. We know that this minus 7 over 2 will take the graph 7 over 2 units to the right, and the graph will also go 29 over 4 minus 29 over 4 units down. So it will be a graph something like this. Now its minimum value is 7 over 2 minus 29 over 4. Or even without drawing the graph, you can achieve this answer by simply changing the sign of this, which is the x coordinate, and retaining the sign of this, minus 29 over 4. So change sign, flip sign, and retain sign. This will give you the minimum value or the maximum value depending on what is being asked in the question. This is also called turning point. So in the question they might just say find the turning point of this expression, which would mean the same. Question number 10, part A, which says x square minus 9x plus 12 equals x minus p whole square minus q. Find the value of p and q. So simply complete square form. So we use the same procedure. We first determine the coefficient of x, which is minus 9. You divide it with 2, we get minus 4.5. So we write x minus 4.5 whole square plus k. We've written minus because of this negative sign. If this were positive, we would have written positive. Now we need to find value of k. So like I said, we ignore this and we write 4.5 whole square plus k equals the constant here, which is 12. So to find the value of k, in my calculator I'll write 12 minus 4.5 square, which gives me minus 8.25. So the question says find the value of p and q. So I am getting x minus 4.5 square minus 8.25. Now in the question we have x minus p. So minus p equals minus 4.5. So p equals 4.5. And next minus q equals minus 8.25. So minus q equals minus 8.25. So q equals 8.25. This was part A. Part B. Write down the minimum value of x square minus 9x plus 12. So we wrote it in the complete square form in the previous part, plus this came out to be minus 8.25. So like we did in the last part, without even drawing the graph, we can find the minimum value of this by flipping this sign, which gives us 4.5, and retaining this sign, which gives us minus 8.25, which is the minimum value of this. Oh, but the question just says find the minimum value of this. And I've written the minimum point, which wasn't asked in the question. I think I've made the same mistake in the previous question as well. So when they've asked for the minimum value, that means they just need the value of the y-axis, not the x-axis, the y coordinate, not the x coordinate. So this is the answer. Minimum value of the graph would be this value just on the y-axis. So the answer is the y coordinate of this. If the question was find the minimum point or find the turning point, then we would have written this. For now we are only writing minus 8.25, and please make this correction in the previous question as well. Part C is write down the equation of line of symmetry of this graph. So for that it's better if we found the point. So we have found the point, and this point is 4.5 comma minus 8.25. Now the line of symmetry would be this line for this particular graph, and this line is x is equals to 4.5. So the answer for part C is x equals to 4.5, and without drawing the graph you can find the value of x, the line of symmetry, by just equating this whole thing to 0. Equate this to 0. X minus 4.5 equals 0 for part C, and you'll get the line of symmetry, which is x equals 4.5 if you don't want to draw the figure. Question number 11. Find the turning point of x squared plus 4x minus 3. So like we've discussed earlier, turning point of a graph that looks like this is actually the value of x and y here. Or for a graph that looks like this, it's this point here, the top point, x comma y. This is called the turning point. Alright, so we need to find the turning point, so we need to first write it in complete square form. So for that, determine the coefficient of x, which is 4, divided by with 2, we get 4 over 2. Then we write x plus 2 whole square, plus because this is positive, and then we add k to it. Now to find k, we ignore this and write 2 square plus k. 2 square plus k equals this, minus 3. So k equals minus 1. So we can write this as x plus 2 whole square minus 1. Now its turning point would be, change the sign, it becomes minus 2, and retain this number with the sign. So minus 2 comma minus 1 is the turning point. In fact, this would be minus 3 minus 4. So I wrote wrong. This would be minus 3 minus 4, which is minus 7. So this becomes minus 7, and this is also minus 7. Alright, next up is question 12. 2x square plus 5x minus 3 can be written in this form. Find the values of a and b. I believe this question has already been addressed in worksheet 1a, I believe, but let's do it again. So we have 2x square plus 5x minus 3, and we have this. Now we can open this bracket, and it becomes 2a square plus 2ab plus b square plus b. Open it, and it becomes 2x square plus 4ax plus 2a square plus b. Now these two equations are equal, which means that 2x square is equals 2x square, which we already know. Secondly, plus 5x equals plus 4ax. So 5x is equals to 4ax, which makes a equals 5 over 4. Preferably write it like this. And then we have minus 3 equals the constant here, which is 2a square plus b. So minus 3 equals 2a square plus b, and this will become minus 3. I am bringing 2a square to this side, so minus 2, and also I have the value of a, which was 5 over 4 whole square plus b. Enter this in your calculators and you should get the answer. Minus 3 minus 2 times 5 by 4 square, which gives us minus 48, minus 49 over it. So b equals minus 49 over 8. Question number 13. Factorize x square plus 3x square minus 10. Part A1, x square plus 3x minus 10. So that should be plus 5x minus 2x minus 10, x common, x plus 5 plus x, minus 2 common, x plus 5, and then we get x minus 2, x plus 5. Part 2. The graph of x square plus 3x minus 10 is sketched below. Write down the values of a, b and c. So let's find c first, because c can be found by simply substituting x equals 0. So I'm doing a2 and I want to find c first. So here x equals 0. So in this equation or this equation, they're actually the same. Let's substitute x equals 0. So 0 square plus 30 minus 10. So equals y. So y is c. So minus 10 equals c, because this is equals to y and y is c. So I have equated it to c, equated it to y after substituting x equals 0. Alright, so we get c equals minus 10. Next we need the values of a and b. So for that, to find a and b in this equation, we have to substitute y equals 0, because here y is 0 and here as well y is 0. So substitute y equals 0 here. So 0 equals y is 0 now. 0 equals x square plus 3x minus 10, and we've already factorized that x minus 2, x plus 5 equals 0. So two values of x are x equals 2 and x equals minus 5. So a would be the negative value because it's to the left. So a equals minus 5 and b equals 2. And next it says write down the equation of line of symmetry of this graph. So line of symmetry is the line that passes exactly through the middle, and let's say if this value was, let's say, minus 3, then the line of symmetry would have been x equals minus 3. So we need to find this middle value. So a was minus 5 comma 0 and b was 2 and then 2 comma 0. So what is the value in between minus 5 and 2? We need to find the value in between these two. So we're finding the average of these two, minus 5 plus 2 over 2, which is minus 3 over 2, which is minus 1.5. So this middle value here is minus 1.5. So the line of symmetry would be x equals minus 1.5. This is answer for A3. 13b. Sketch the graph of y is equals to x 18 plus 7x minus x square. Now for this we have to follow each and every step we took in part A. In part A, first we were asked to factorize the given equation. We will also factorize this equation. So we will factorize 18 plus 7x minus x square. So to factorize that, we're looking for two numbers which when multiplied should give minus 18, added should give 7. So that would be minus 9 times minus 2. Yes, and 9 minus 2 is 7. So 18 plus 9x minus 2x minus x square. 9 is common here, so 9, 2 plus x, then minus x is common, so 2 plus x. So the factorized form is this. For part C, in fact we're yet to sketch this graph. And also I wrote this wrong. 9 minus x and 2 plus x. So this would be 2 plus x. Alright, so in let's go back to part A. First we had factorized that, then we had sketched the graph using A, B and C. So similarly we'll sketch this graph first by substituting x equals 0. So when x equals 0, what do we get for y? So if I have y equals 9 minus x 2 plus x and I substitute x 0, then I get y equals 9 minus 0 2 plus 0, which gives me 18. So when x is 0, y is 18. So let's say 18 is somewhere over here. So this would be where the graph will cut the x-axis, like here it cut the x-axis in part A, it cut the x-axis here, sorry, the y-axis here. Ours would cut the y-axis here. So this point is actually 0, 18. Okay, next up we need to find the 2 points where the graph cuts the x-axis. So here again we'll substitute y equals 0 instead. So I'll do the rest of the working here. So for that I'll write y equals 9 minus x and 2 plus x, and y is equals to 0 because here y is 0 and here y is 0, and we're exactly following the pattern of part A to do part 3, to sketch part 3. So 0 equals 9 minus x and 2 plus x, so we get x equals 9 and x equals minus 2. So our graph will cut x-axis at minus 2 and 9. So let's say 9 is somewhere over here. So our graph would look like this. I hope you make a better graph than me. Alright, so this is the sketch for part B. Part C. X square plus 12x minus 7 can be written in a complete square form. So for that, first write the coefficient of x, which is 12, divided with 2, we get 6. So we write x plus 6 whole square plus k, and to find k, ignore x and the sign. We get 6 square plus k, write 6 square plus k equals minus 7. So you get k is equals to minus 7 minus 36, which gives us minus 43. So this is x plus 6 whole square minus 43, which the question said should be written in this form. So here plus p equals 6 plus 6, so p equals 6, and minus q equals minus 43, so q equals 43. Write down the minimum value of y for this equation. So we're still talking about this equation, and to find its minimum value or the turning point, or in some cases the maximum value, we flip the sign of plus 6, so we get minus 6, and we retain the sign of this, so we get minus 43. So the minimum point of this graph would be somewhere over here, which the point is minus 6 minus 43. The question was find the minimum value of y, not the minimum point or the turning point. So the answer should be minus 43 and not this in the form of x and y. This is the answer. The minimum value of y, not this. You may write this down and eventually write this, but in the end you will get the answer for writing minus 43. Alright, that's all.